Hey everybody, you're listening to A2Z episode 29. Today's guest is Lamar University adjunct professor Amanda Allison.
It's like they're trying to be too meta.
You're gonna make them an offer they can't refuse.
You can
buy you a drink. You can.
well, I mean, he did pick out somebody we know.
Will you sidestep the question? That technology does not exist.
Hey everybody, what's up you guys? I'm Aaron. I'm here with my co-host Zach.
How's it going?
Welcome to A to Z. If this is your first time listening, thanks for checking us out.
A to Z is produced sorta weekly, and show notes can be found at a2zpodcast.com. And if you like what you hear, feel free to hit subscribe on Apple Podcasts, Google Podcasts, YouTube, Stitcher, Spotify, or wherever else you get your podcast fix.
As you can tell, some of those apps have actually changed their name.
Yes, you will not find us on Google Play Music anymore. No new episodes. They're always going to be on Google Podcasts, which is a new app they just put out.
There you go.
Didn't tell anybody, apparently.
Right, but we're basically on any app that has podcasts.
And if you don't find us on your app, let us know. We'll get on it.
That's it. And then, as always,
iHeartRadio, too. Yeah.
Oh, yeah, that's right. That's a new addition, too, iHeartRadio. All that in mind, you can also follow us on Facebook, Instagram, and Twitter at A to Z BMT, where you can interact with us. You can find updates, clips, extra content, like something I posted today.
Old Gator Country doing some work.
That's it, yeah. Just stumbled upon somebody getting an alligator out of a ditch. Yeah, that's how you keep up with us in the community.
So today's episode, we have Lamar University adjunct professor Amanda Allison. She teaches space science classes. So she teaches space science, space exploration, and remote sensing. She has degrees in human factors and aviation, basically.
Right. So her study is basically like biology in space. Mm-hmm. A lot of it has to do with what our bodies go through in microgravity, and a lot of it's very theoretical.
So we talk a lot about that, a lot about space travel in general. Then we get off on some tangents as usual. Yeah. But also, we wanted to get back to what we did with Lyra Parrish.
Yeah, so on last week's episode, we had a giveaway. Lyra Parrish, she came in, she brought 3 books. She personally signed all 3 of them, all 3 different. And we told you guys last week, if you were a subscriber and also you liked us on either Instagram or Facebook and just left a comment somewhere, you would be entered in. We randomly would dole these books out. And we've actually picked 3 recipients of a book. We picked, the first one was Melanie Adams 3.
On Instagram?
That was on Instagram. She gave us a shout out. I think she's a fangirl of Lyra Parrish, which is really cool. So give us a message. We'll send you a message. The other one was Hannah McMahon. Mm-hmm. Good looking out, Hannah. And the last one was Brian Castino. Yeah. So you guys holler at us. You got some signed books. We'll get you some books.
We're going to give Melanie Adams first pick because she was the first one.
She was the first one to comment.
So she gets first pick. We don't have the list of the books. They're at my house, But yeah, so anyway, so that's what we have going on. We got giveaways that we have happening. We're going to try and do some more things in the future, but we just keep in touch and we'll see what's going to go on. But if you like what you hear, always feel free to hit subscribe, leave some reviews. Leave us some reviews. Tell us if we're doing a good job. We'll keep doing it. If you don't think we're doing a good job, what we can fix or anything we can learn from, we would be more than happy to hear.
Or if we made mistakes in the podcast and maybe misspoke. We do that all the time. We're human. Yeah, correct us. We don't mind.
But we love talking to you guys. We love it when you reach out to us, and we just want you to enjoy this episode with Amanda Allison.
I love dogs.
Dogs are nice.
I love dogs too.
I love dogs.
Well, we are here with Amanda Allison. This is Amanda. She teaches, what class do you teach exactly?
I teach space science and remote sensing.
Remote sensing? At Lamar University.
Yes.
Shout out to Hannah for hooking us up.
Thank you, Hannah.
Because she told us about you, and then I was like, that would be a really cool person to have on. And then over the course of a few weeks with you canceling and us canceling and everything happening, we kind of and we've been pausing on this interview because we have the yard people outside making noise. But you're finally here, and we're happy to have you. Thank you for coming.
Yay, thank you very much.
And she brought her little pupper along. Hannah posted a picture about there being a dog in her class, and I mentioned it to Amanda, and she was like, yes, I'll bring him, and his name is Crater.
Yeah. Actually, shout out if you like dogs and you're into that type of thing, go to Doggos of Southeast Texas.
Yeah, Doggos of Southeast Texas. That's Hannah's.
It's a fun little community
on Facebook, and you can share dogs and share with dog lovers. And I think she even plans community events and like go to the dog park and stuff.
Like a doggo meetup.
I'm down for that.
Park, yeah.
But thanks
a
for
dog
coming.
Meet and greet.
Yeah.
Yeah. Do you want to tell people about yourself, like what your background?
Okay, well, right now I'm an adjunct professor at Lamar in the Earth and Space Science Department. I have a master in aeronautical science. I'll get to that in a second. So I used to work in the medical field, and I did ultrasound. I have a degree in that.
Oh, wow.
And I hated the medical field. There's so many cutthroat people.
You must be really good at school.
Yeah, I really am.
Yeah.
It wasn't for me. I was totally turned off by a lot of corruption that I saw.
In the medical field?
Yeah.
Oh, wow.
Yeah, I can't even tell some of the stories
Was
because I'm legally bound not to say anything.
Oh, yeah.
Did you see a lot of situations where people might just need an ultrasound, but they would try to upsell them to like an MRI or something?
No, it was more along the lines of you have 90-year-old ladies coming in and that are bleeding or whatever, and they're old, and they would do like useless ultrasounds on them, like transvaginal ultrasound on a
for like the
90-year-old
Medicaid.
lady.
Right.
Yeah, and
To make more money.
That stuff was just really upsetting.
It's like, of course her bones are broken. She's fragile. She's 90.
Yeah,
Yeah.
and then there was the aspect of, seeing babies that had died and stuff like that. And you're
Yeah.
not supposed to tell parents, but they know. So I just...
What, they died because of, like, they
They just died.
Just babies die in utero.
Yeah.
So it was just depressing all
It's
the
a
time.
rough job, yeah.
Yeah, and I said, this isn't for me. So I went back for my bachelor's degree because I wanted to anyway. And I got into the geology department. Dr. Jordan helped me to get my bachelor's of applied arts and sciences because ultrasound is mostly physics. A lot of people don't realize that.
Oh, yeah, of course,
Heavily
yeah.
physics-based.
Yeah.
Of course.
You have physics of sound and physics of light and pretty much every kind of physics that
And
there is.
density.
Yeah.
Yeah.
And so I got that bachelor with a space science minor, and that was pretty cool. But when I graduated, I couldn't find a job in the area because I'm a female and I'm a scientist, and I don't really work in the industrial field.
Mm-hmm.
One of my friends tried to get me on in one of the research labs at one of the plants, but I don't have a chemistry degree.
Yeah.
So
Wait, plants have research labs?
yeah, research
yeah.
and development, yeah. And they require a very specific degree.
Yeah.
So
yeah.
Dr. Jordan and one of my former mentors, kind of talked me into going to Embry-Riddle Aeronautical University because that's where somebody else went that we knew. And I was really scared to do it because it was all about aviation and aerospace. And I was in there with lots of military people.
Oh, yeah. I can imagine.
I fly an F-18 or an F-8, F-15 or whatever. And,
I'm a Blue Angel pilot.
But I ended up doing really, really well, and I really liked it a lot. I love aviation and all that. And I ended up graduating with a 4.0.
Nice.
Like,
Oh, wow.
a lot of the military people, they don't think outside the box.
Yeah.
So I was, had like a
They're usually very focused
little
people,
gift where I would think about things differently, and it helped me.
Yeah.
But Dr. Jordan hired me. He had a job for me before I even graduated, which was awesome.
So you got a degree in...
I have a Master of Aeronautical Science, and my specialization is human factors in aviation and aerospace. So memory and cognition, human-computer interaction. There's lots of psychology. How people work together.
User interfaces
in
and stuff.
groups, leadership styles, management styles, how you follow,
Yeah.
what type of personality should not work with what type of personality.
But also because if you're fitting everybody into a tin can together, you kind of have to...
You don't
Fit 'em
want
together.
to be sitting right next to like this major type A personality if you're talkative and bubbly like I am.
Yeah.
I have a best friend that's like that, and I love her, but we can't live together.
Well...
So, there's a lot of psychology that goes into that. So part of what I do every semester when I teach is I read my students, and they don't even realize it.
Yeah. Yeah, that's what teachers should do. They should figure out what they're getting into.
I mean, is part of the wheelhouse also physiology in space too, like circulation?
Absolutely.
And how,
Yeah, that's
Yeah.
actually one of the big things that I teach about because it's not in our textbook. There's nothing about the human aspect of exploration in the textbook that I use. So I give like specific lessons on the way that the human body changes in space, the physiological changes. Even
do you also
psychological changes.
extrapolate like hypothetical situations of humans on other planets?
Yes.
You think about humans on Mars and the reduced gravity and
Yes. Yeah. Yes. Yeah, I could go into like so much. You can get me off on a tangent and that kind of stuff, but absolutely.
We do tangents on this show quite often.
Oh, we're looking for some tangents today.
Yeah,
honestly.
Okay, so the moon is a sixth of the Earth's gravity.
1/6, yeah.
And Mars is a third of the Earth's gravity.
It's a third in Mars. And
yes,
a sixth
it's a third.
on the moon.
Yeah. So.
So that means.
It definitely means that the moon is more dense than Mars, but yeah.
Okay, so you would. But your body weight would be like that, right?
Mars has a very, very thin atmosphere.
Very thin, yeah.
A long time ago,
A thin,
something
wispy atmosphere.
very, very large knocked into the planet and knocked a big crater on one side of it. And if you look at images of it, there's these huge drag marks across the planet.
Like it just bumped and just like it was a little hit and run.
One of the theories behind
celestial
it
hit
is
and
that
run.
the asteroid belt actually used to be a planet, and maybe that's
Yeah.
what collided into Mars.
Yeah.
Oh, so the asteroid belt used to be an actual planet itself.
That's a
Could
theory.
be. I don't
It's a
know that
theory.
for a fact.
Yeah,
it's a
yeah,
theory,
yeah.
but it's a very good theory.
Yeah.
It's very
It
compelling.
makes a lot of
theory,
sense. Yeah, it's very compelling.
I mean, because they are...
Poor Mars.
I mean, the asteroid belt's locked in orbitally
Yeah.
around the sun, just as if it were a planet between
Yeah.
Mars and Jupiter.
Do you think that's what killed the original Martians? Maybe. I was joking.
I really don't know if were there original Martians.
but okay, so what you're talking about gravity and
So there's barely any atmosphere. It's very thin. Earth has a huge magnetosphere. It
Yeah.
emits a giant magnetic field which protects us from a lot of solar radiation. Mars doesn't really have that. So if you look at the surface of Mars, it's all red and it's oxidized and
But the magnetosphere is independent from an atmosphere, though, right?
yeah,
Yeah.
it is, but they coalesce with one another.
Sure,
And they work
okay.
in tandem with one another. And the different layers of our atmosphere have different jobs that they do, which is why the higher up you go in the atmosphere, like if you go in the stratosphere where commercial airliners fly, if you fly 3 times a year, you have an 85% higher risk of developing cancer because you have less protection from radiation. Plus, you're in the plane with all the radar emitting frequencies and such.
An 85% chance?
85%, yes.
So you're telling me that all of these executives and all these A-list celebrities that fly private
are
higher
very
chances.
much being bombarded with radiation.
they're going to get a tumor?
yeah,
Yeah,
well, I
on
mean
a regular basis.
they're loaded, so they probably have those
And then,
CRISPR
and then
things they
higher
can
up in the stratosphere, a little higher up than what we fly,
Yeah.
there's less protection from solar radiation. So, you're being bombarded with all of that. And the human body's not meant for that.
That's a pretty interesting thing that you did. You dealt with ultrasound's kind of like a radiation kind of thing, right?
No
Sound.
radiation.
Okay, I was thinking
no
X-ray.
ionizing radiation. X-ray is though.
Okay, I got confused.
The X-ray techs wear little Geiger counters on them, and
Yeah.
when they
We got a buddy
reach a
of ours
certain
that did
limit,
that, yeah.
they have to sit out for a while.
I used to work with cesium-192 and americium and all kinds of stuff. I used to have to wear not a Geiger counter, but a dosimeter
Yeah,
all the time.
yeah. I mean, it does bad things. So that actually leads into what you had wanted to talk about with the twin
twins?
brothers.
Yeah.
Yes.
Well, Will brought that. I mean, we had asked Aaron. We'd all asked about it, but it'd be
Yeah.
It's definitely interesting though. Like one of the brothers spent a year in space, and they look completely.
Well, they were
different.
identical twins.
Right,
That's the most
they're
important
identical
thing.
twins, Mark and Scott Kelly. Okay, so first of all, when the astronauts go up there to the International Space Station, they typically only stay up there for maybe 2 weeks at a time,
Really,
or
so short?
maybe a month. Yeah, they're not usually up there for long stints.
Yeah.
So just the fact that I can't remember which brother stayed and which went, but just the fact that the one went up there.
They're both astronauts.
Yeah.
Oh wow.
Yeah. So they've both been to the ISS too. So one of them went up there for 500 and something days, which is totally, completely groundbreaking, unprecedented,
very long.
has not been done before. And the other one stayed down on the Earth so that we could look at the difference between their physiology, how the long-term effect did on the astronaut that went up there. Because we don't have any long-term studies on the human body up there. We just know that it does all kinds of horrible things to the body.
Very horrible things.
But, yeah, all kinds of horrible things. And I'll go into that in just a minute. But what it did to him was it mutated his DNA. And this is the strangest thing ever. Like, So there's this thing called the twin paradox, okay? So the further you are away from a large object, a very large, massive object like, say, the Earth, the faster time runs. Because there's less drag from gravitational field. So even though time runs faster, you age slower in space. So the person on the Earth would age
by a very tiny margin, though.
Unless you're like
tiny.
way far away.
Right.
Way far.
And then the person on Earth would age like way faster, like 50% faster. So the twin that went up there, he's exposed to all this radiation in space for over a year. It mutates his DNA. On your DNA, at the ends, you have this thing called telomeres. Yeah, and as you age here on the Earth, your telomeres will shrink. Yeah, and so it leads to deterioration in the body. His telomeres, 9% of his DNA mutated permanently, and his telomeres grew longer. So
what does that mean?
That's the only time anyone's telomeres have actually grown.
It's like it would it'd be life expanding.
Yeah.
It would help him to live longer because those telomeres are not shrinking.
It's a direct correlation. Your telomeres shortening is like termination.
Yeah.
There's a complete and direct correlation between your life.
Okay.
Yeah. So his
he
telomeres
grew?
lengthen. Yeah.
Has that ever happened?
Not that we're aware of. No.
It's pretty amazing.
It is.
So space travel is going to be the key to
It is mind
eternal life.
blowing, but so much bad stuff happens to the body. So your blood flow changes, your hydrostatic pressure in your body. Your blood flow will redirect itself because in the vacuum of space, which there is gravity, that's a misconception that there's no gravity.
In orbit, you're at like 97% the gravity that you're on the Earth. You're just constantly falling. People have
you're in a state of free fall.
Right.
Yeah.
But
there is gravity in space. It's just less than what we're used to on Earth, so they call it microgravity. So less than that of the Earth. So, but they're in free fall. But they're exposed to all the stuff. So the first thing that happens when you're in that state is that your blood flow changes direction in your body. So your limbs, your arms and your legs, they don't need all of that. So it redirects towards your heart
and your organs,
your lungs where it's needed. So your chest will puff up and your face will get puffy and make you look younger. Your spine extends. So
I can get rid of my wrinkles?
You can get rid of your wrinkles.
Shoot me out to space.
For Botox.
Live longer
Botox
and get shot out into space,
I want my DNA to mutate.
It makes your eyesight deteriorate. So
he has that written down too. Eye health.
Yeah. So your vessels in your eye will constrict and they'll start to deteriorate. So they do ultrasounds on their eyeballs to look at the
I guess with
to
your
look
eyelid.
at the physical changes.
So you have your eyelid down, or just like straight up on your eyeball?
I think they do it directly on the eyeball because it's gel.
Okay,
it's not
that's fun.
bad
You ever
for
touch
you,
your
but
eyeball before? You just
but I don't want some strange machine on it.
Your muscles atrophy. Your bone
density depletes.
Yeah, deteriorates.
Well, because you're not putting any weight on it.
Yeah, so they have to do all these exercises every day, and they eat like kilocalorie meals full of antioxidants like vitamins A, K, E, D, you name it, potassium, and all that kind of stuff.
Do they eat all those antioxidants to try to combat the free radicals from cosmic radiation?
Yes, exactly.
What exactly are free radicals?
Free radicals are these little things that you have in your body, and if you have any kind of cancerous-like growth, they will attach themselves to that, basically.
And become cancer.
Yeah, and it'll make it, like, aggressively spread or grow.
So free radicals are like a conduit for cancer to go.
Yeah, exactly. And everybody has free radicals in their body, but you don't want to have, like, an overabundance
It's just
of
such
them.
a ridiculous name. I always thought it was, like, kind of made up. It's like free radicals, bruh.
So, their diet is meant to help to alleviate that. I don't know how well it works because a lot of former astronauts have died from cancer.
Would you say most of them? Other than why did Buzz and all those guys live so long?
Because they never went to the moon.
Oh yeah. Oh, that's right. Yeah, that would make sense.
Because they're fakers.
I think that we did go to the moon. I don't know
if the footage is real.
Yeah. Like the footage may have been faked. But if you ask Buzz about it, he'll get really pissed off. Yeah, exactly.
He'll punch you in the face.
Exactly.
He
like,
has.
I think that there's a lot more going on there than they let on.
Yeah.
Yeah, because he's like 90.
Well, people have this really weird sort of they have this way they start thinking about something whenever you start talking about a conspiracy. And when you start thinking about a conspiracy, your nuance of thought goes out the window, and you just start thinking of everything rudimentary as true or false or did or did not. And with the moon landing thing, because my older brother, the last time I went on vacation, he's like a moon landing denier. And I was,
who?
My older brother.
Oh.
And I had this conversation, and I was like, well, it's not so binary in thought of this. Like, maybe a lot of the aspects of the first moon landing were fake, maybe, but maybe we also landed on the moon. I mean, obviously it's clear there's facts that we landed on the moon. There's a optic prismatic reflector where you can aim a laser to the moon and the exact coordinates where people put it,
Right.
and you'll get the reading back. There's many things that you can tell that we went to the moon, but we went to the moon 6 times. Maybe the first one might have been faked. Who knows? But I just think it's funny whenever people start talking about conspiracy theories, how they just like throw subtlety and nuance out the window, and it's either like yes or no or false.
Right. Yeah, and in my mind, I think that we did actually go to the moon, but there's something's covered up because they lost so much footage and data and whatnot. I don't think they lost it.
I think it was just corrupted, honestly.
I mean,
Yeah.
radiation will affect film cameras.
They had specialized shielded Hasselblad medium format cameras when we went into space, but
Yeah.
I mean, who knows? I don't know.
Yeah, it was just...
Have you been seeing an increase of students in your class that are talking about things like that?
Oh, yeah.
Because I would figure that you would have people coming into your class that would like be looking for stuff like that to talk about. So,
But they're really hesitant to ask me about stuff like that.
Humans can't go outside the Van Allen belt. Don't you know?
I will usually, like, students that have questions like that, they'll come ask me after class.
Yeah,
So they don't
they don't wanna
disrupt. They're
embarrass
always really
themselves.
polite about it,
Yeah.
and I've been really impressed with my students.
what about flat earthers?
I have not run into one of those yet.
God.
You ever
Oh,
see
yeah.
anybody in the back of the class just getting pissed off? Like,
That hasn't happened to me yet. And actually, my boss is like, "Don't pay them any mind."
Good.
But I'm not like that. I'm like, no. What I
We'll
want
talk
to
to
do
them. Yeah.
is, I've studied all their different models and how they.
All the different flat Earth models.
Yes,
Yeah.
I've actually
that's-
sat and studied them in length
Yeah.
because I'm like, one day I'm going to meet one of these people, and I need
You have to know their
I need
language.
to know what they're
no,
talking
pull
about.
up example C176 from
So,
Dr. Ep029 on YouTube.
So I have a freaking aviation degree,
Yeah.
and I know a lot about the Earth and how it works and what's going on. And there's just certain questions that the flat Earth theory does not answer, like how do you explain the Coriolis effect? You know,
Yeah.
which is the air currents, which drive the ocean currents. You can see that
Yeah.
on satellite. You can see those ocean gyres turning.
I mean,
with
snipers
the
have to deal with the
effect.
Coriolis
Yeah,
effect,
they have
so,
to take
yeah.
that into account when they shoot. Pilots have to know about the Coriolis
Right.
effect. My husband flies helicopters sometimes,
Oh, wow.
you know, and you have to understand because if you get caught in a downdraft or an updraft, it can kill you. So there's the Coriolis effect. There is Rayleigh scattering from the sun, which only occurs in the evenings because of the angle that the sun is at. That's when you get the pretty reds and pinks and purples in the sky
Absolutely, yeah.
because the sun is going down at a certain angle over the horizon.
And it's
I was
going
telling
through,
somebody about
it's
that
going
the
through
other day.
more atmosphere than if the sun were directly overhead, too. Yeah.
It's counteracting those blue wavelengths, and so you're seeing the red wavelengths
That's
of
what it
light
was.
coming through.
I was at
yeah.
the creek and I was looking up and I was like, it's so crazy that like the only reason that the sky is blue is because the light from the sun is hitting it at a certain angle.
And because of the water, because the oceans, the Earth
The
is,
oceans reflect back.
the blue wavelength can only go so far down in the water.
Right.
But that's what it reflects back is mostly blue because
Yeah.
the red can penetrate further down.
Can you imagine if it wasn't that and it was just black sky with the sun sitting in it? That would be ridiculous.
If the Earth wasn't covered in as much water, the sky would be a different color.
Yeah, everything would be.
So
yeah.
Mars, that's why Mars kind of has like a grayish sky.
It's dark and dingy looking.
Yeah, it looks
Yeah.
like
Yeah, it looks like
dusty.
space.
I don't know why people want to colonize Mars because it would literally drive you crazy.
Yeah,
Yeah.
well,
It would affect you
Well, and then you're
very much
if you had
psychologically.
a child, they would be fucked up.
It would.
Do you imagine
their DNA would be so.
We don't even know if a human being can carry a fetus
Through
in
space.
utero through space because of all the radiation.
Right.
Because it mutates the DNA.
Yeah, and the baby's being built at that point, so you can't really
And
mutate
then
anything.
the change in blood flow is up towards the lungs and the heart. So
you
know
might
if-
just like starve to death.
Yeah.
Yeah. That's really dark.
God.
Yeah.
Yeah, so it's really interesting.
The time thing. You were saying that with the Kelly brothers that you age 50% faster or something like that on Earth. What would that be like if we actually colonize Mars? Like what would be the time zone difference between Mars and Earth? Like
I have no idea. I can't
NASA has they have a Mars clock you can go.
Yeah. They do. I can't remember what the communications delay is, but it's pretty large chunk of time.
like minutes, right? It's like 15 minutes or something.
I think it's like hours, depending on which side is facing towards you or away.
Yeah.
Because if you're on the opposite side of the planet, you're kind of screwed as far as
the communications. What would be the communication be based on? Radio waves.
Yeah.
Yeah.
They travel the furthest. They have the longest wavelength.
That's what we're sending out into space for the aliens.
Yeah. With some weird stuff attached to it.
So like a pure distance is like the sun to the earth, and light speed is pure. It's like 9.8 minutes for light to reach.
Lasers?
Yeah, that's about 8 minutes for light to reach the earth from the sun.
So from Mars,
the speed of light is 300,000 kilometers per second.
Right.
It's like 1.9.
Didn't they just now figure out what the speed of light was?
Miles per second. We've known that for quite some time, decades.
I was thinking they discovered something, but I don't know what it is.
Now, in Einstein, or it wasn't really his formula, it was already a formula out there, but he figured out the missing gap. Einstein did for E equals mc squared. The constancy of the speed of light wasn't accounted for in that.
That's what the E is, right?
That's a C.
That's right.
E equals energy, M is for mass, and then C is the constancy of speed of light squared. Energy and mass are directly related to one another. So if you increase your energy, your mass is going to increase. If you drop one, the other will drop two. So basically, the faster you go, the more massive you become. And everybody always looks at me really wide-eyed whenever I explain that. But the faster you go, the more it compresses all of the molecules in your body. So it makes you denser and denser and denser. So it makes you more massive. It's making your density, compress you more and more and more. It doesn't make you bigger.
Yeah, it just makes you denser.
Yeah, exactly. So that whole weight and mass thing always blows people's minds.
Yeah, my mind is kind of like... It's turning a little bit right now.
One of my favorite things to do is to just have discussions like this in my class. We have actual class discussion days where I will totally just mind fuck people. And the looks that I get back, sometimes it's worth it. I mean, I just usually will giggle, and I'm like, I made a thing.
How long have you been teaching there now?
I'm in my 5th year.
Okay, it couldn't have been. We had a buddy of ours, Nathan, that told me that he had a space science class that and he told me they were talking about time and how it changes the further you go out, or how far away the stars are, or something like that. And he was just like tripped out about it. And it was like it was really cool to hear that they had some kind of class like that at Lamar where there's somebody blowing some minds,
Yeah, relativity is my favorite.
Time also dilates whenever you're around a gravitational anomaly too. So it's,
yeah. So if you were going to take a trip, this is hypothetical, around a black hole, if you're far enough away from it to not be sucked into the gravitational pull, if it was a 16-minute trip around this black hole, okay, and you're going close to the speed of light, not the speed of light. We'll say you're going 99% the speed of light. That 16-minute trip around that black hole for the people that are inside the spacecraft would only be 8 minutes.
Yeah.
It would be cut down by half.
There's a really interesting Star Wars theory about it too, because the whole...
The Kepler run?
Yeah, the misnomer, the 12 parsecs.
So that's a distance measurement.
Right.
So some supreme nerd
filled the plot hole.
They filled the plot hole by talking about he's talking about distance and the way it relates to time by explaining how Han Solo utilizes black holes to shorten his
Right.
time.
Yeah.
So and then they were like Han Solo's 237 years old because while he's smuggling, he just like takes full advantage of it. Yeah.
That's interesting.
Yeah.
Yeah.
It's nerds.
I love nerdy stuff, though. It's so
Me too.
fun.
Hey, creator, come see me. I just want to pet you so bad. Oh.
So, yeah. So, all the radiation changes. Okay. So, before we started this, there was a mention of astrology by accident. But I will tell you something that's really interesting. There may actually be something to that. I'm not saying that there is.
The treat.
So, don't chastise me or whatever, but there actually could be, because of the way that the human body develops. Certain organ systems develop at certain times. Your brain makes certain changes at certain times in utero. So astrology is based on the alignment of everything in the universe at the exact moment that you're born. So the alignment of the sun, the alignment of the moon, even asteroids and comets and all that stuff. But the gravitational effects from the moon and the sun have a direct effect on the chemistry of the human brain, which is why when there's a full moon, it seems like people do crazier stuff. I used to work in the hospital, so I know, I've seen it. It's true. It really is true.
Oh, I'm sorry. Mercury is rising today. I'm not my element.
Mercury retrograde is awful. It actually is really bad. I've had experiences that were bad in that. But so anyway, depending on who you are, what month you're born, what day, what time, all those planets and everything are aligned differently. So it could actually have an effect on your personality directly by how much gravitational pull from the sun or the moon, how close we are at that particular time to the sun, because it changes.
If the gravitational pull can move oceans, and I'm sure it could probably even affect somebody as small as
it does affect the human brain. It changes the chemistry of the brain. So solar radiation changes the brain chemistry and the way that it operates, because your brain is operating off electrical impulses just like everything else in the universe pretty much. So anything that can interfere with that can change the way that you think and see and perceive
so
things.
What you're saying is there is a direct relationship to our very close celestial neighbors and our physiology.
Yeah.
So
it does affect the way that you develop.
And this kind of harkens back to when I was talking about the conspiracy. Is people they don't have really a nuance of thought. So maybe that aspect of astrology might be true, where some things outside of our Earth might influence our physiology, but at the same time, they're talking about constellations.
Right. But
So
it has more to do with the gravitational effects of the moon and the sun.
But the moon and the sun are very, very close to us.
Yeah.
And Sagittarius and Aquarius, these constellations have absolutely no gravitational effect on us whatsoever.
Yeah, I guess so. I never really thought about it like that before, but it does change the alignment in the heavens. But
that's the language of which they speak, right? So you're saying A and they're saying C, and I'm trying to connect it with B.
They take into account the alignment of all of the planets in the solar system as well, because there's certain stuff that gets in the way of other things, which would block frequencies from certain directions and whatnot. So I don't know if there's something to it or not.
Frequencies of
but there could be all the energy that comes toward the Earth, because we're constantly bombarded with energy from space.
Oh yeah. We're constantly bombarded with. That's why our magnetosphere is pretty dope.
Yeah, our magnetosphere is amazing. Actually,
thanks for being made out of iron, Earth.
Yeah,
I appreciate it.
So we have a pretty good sizable magnetosphere. Jupiter's is way larger.
Yeah.
The sun's magnetosphere is ginormous, and we're actually, if you want to be realistic, we're actually still inside the atmosphere of the sun.
Yeah,
where we are here on the Earth.
We're inside the ionosphere.
Yeah, it's very active. The sun's very turbulent and has lots of effects on human behavior.
It's a big one, right?
Thanks, son. No, it's actually small to medium.
I mean, I put on sunscreen. You see I'm a little sunburned. So it does have an effect on me.
So
I get sunburned
there
all the
was
time.
this discovery made. I don't know a whole lot about it yet because I haven't had a lot of time to look at it. But the European Space Agency actually came out, I think, about 2 weeks ago. They discovered a second magnetic field around the Earth. And if I'm not mistaken, I believe that
I was seeing that on
we
YouTube.
created that somehow.
Mm-hmm.
I haven't gotten to look into it very much, so.
I think we're having more of an effect on everything than we think.
Oh, by far. So,
You mean first now I got to deal with climate change. Tell me right now I got to deal with solar change too.
Magnet
So-
change. What, we saying we're magnets now?
How in the world?
Let me tell you
how in the world
how
can I
crazy
affect
this
the sun?
is. Let me tell you how crazy this second magnetic field is, though. When they discovered it, it also coincided with all these weird animal migrations.
Oh,
So
yeah?
this big conglomeration of like
especially avian species. I'm sure.
1,400 basking sharks conglomerated together in the
Oh,
ocean.
wow.
That's like unheard of.
Yeah. They're very solitary
Birds
sharks.
started getting confused and they changed their migratory patterns. Because that's how they see magnetic fields. That's how they migrate. They can actually see them. Fish, whales and stuff, whales and dolphins were
I know
beaching
the
themselves
mantis shrimp
around
can
the
see.
same time that they discovered this.
Didn't
So
the poles just flip?
No, not yet.
not yet. We're in the middle of a pole reversal.
Yeah.
Yeah. This is a normal cyclical pattern of the Earth.
Every 80,000
I'm ready for
years, so.
maximum overdrive to happen.
The magnetosphere of the Earth weakens whenever there's a pole reversal. And so I think we're seeing a lot of the effects of that right now.
Yeah.
The polar regions of the Earth are weak spots. If you look at images of what our magnetosphere looks like, it's like a doorway into the polar region. So if they ever get hit by like really big solar flares or coronal mass ejections from the sun, that can actually like majorly weaken the magnetic fields around the Earth and have like catastrophic effects for human beings. I mean,
Like, what is a magnetic field? Is that what's protecting us?
yeah, so if you ever look up images online, our magnetic field looks like it's not a big bubble around us. On one side, it's like a donut shape, and on the other side, it kind of spans out a little bit further. The solar radiation from the sun, all of those charged particles will come hit the magnetosphere, and a lot of that will be redirected around and go off into space. And some of it will come in and enter the atmosphere through like polar regions, which is why you see those beautiful auroras. You see all those charged particles interacting with our ionosphere.
Everybody go look up, just Google
Yeah.
magnetosphere Earth. And that is, wow. Okay, so
So you get auroras. You can see those charged particles interacting with the planet. You can even tell what kind of gases they're interacting with by the color that comes off.
the top part, is that the North Pole and South Pole?
Yeah,
Okay. And
kind of looks like a spider.
yeah, it does look like a spider. It's got an abdomen and like,
Yeah, it's like a black widow.
and this is what's facing the sun.
Yeah.
So the sun hits it, and that's what happens to the.
Yeah, and you
that's-
see how on that side it kind of compresses it inward, and then
Yeah.
on this side is further away, so it kind of is stretched
kinda
out.
stretches it out. Yeah, because it's getting what's coming around,
Yeah, exactly.
and this is what keeps us alive.
Yeah, this is what protects us and makes it safer for us to be on the surface of our planet than anywhere else that we know of so far. Like,
Is this
But
part of that Goldilocks zone thing?
yes, we're in the Goldilocks zone, and Mars is in the Goldilocks zone.
Right.
But Mars has barely any atmosphere and barely any magnetic
Like anything.
field.
Yeah.
Well, all we have
So-
to do is explode about 2,000 nukes on the surface of Mars.
That's
and
what
we'll-
Tesla wants to do.
We could
that's what Elon Musk was-
terraform it and cloud seed. You know, there's that whole geoengineering.
I'd like
thing.
to. I mean, what are we doing with Mars anyways?
Which leads me to my next point.
couldn't live on it.
Geoengineering is not a conspiracy, people. It is real.
Yes, they
NASA
do have cloud seeders.
Yeah, NASA has a cloud machine in Mississippi.
Yeah, they release metallic nanoparticles into the air.
To
So
reflect
aluminum,
things back, yeah.
barium, strontium, lithium.
Barium. We have barium in the atmosphere.
Yes.
Aren't they always in the atmosphere? That's
go
part
look
of
on the NASA
atmosphere.
website. It's up there. It's
Why
for
are
everybody
they-
to read.
So somebody's putting barium in the atmosphere? Why?
They
Why would
s-
somebody put that in there?
What I read was that because of global warming, the Earth is heating up. So they're releasing all this stuff into
To
the
bounce stuff
atmosphere
back.
to reflect
Oh, sure.
solar
Okay,
radiation.
okay,
Now,
that makes sense.
only
But it also
now-
reflects stuff inside too,
Yeah,
right?
and you breathe it in, and it rains down.
I don't want to breathe in aluminum. Aluminum causes Alzheimer's.
Well, there you go.
I don't want to breathe that.
Yeah, that's why you don't use deodorant, right?
I don't,
lithium.
I don't use deodorant for the most part.
There's
unless
lithium
I'm
in the
actually stinky.
atmosphere that
Yeah.
they put lithium in the
Lithium's
atmosphere.
for calming people down. right?
Lithium's
just salt.
Lithium's for no.
It's a salt.
Yeah, but salt is a molecular term, but it's not sodium chloride.
I know.
Yeah, aluminum can be a salt too, but it's still not good for your body.
It's going to assault your brain.
Aluminum
Right.
salts, yeah.
So
you don't assault people.
geoengineering is actually written about in the Geneva Convention not to use weather warfare. Yeah.
Well, it's also, don't use space nukes, but I'm pretty sure
Yeah,
there's some
so
nukes up there.
NASA has
Space
said that
nukes,
they do
yeah.
this.
Yeah, no warfare in space is one of the geoengineering.
So people that see chemtrails, they're actually seeing chemtrails. I mean, it's not a secret anymore.
Those are
They
contrails,
exist.
though.
Those are contrails, yeah.
Well, there's a difference between contrails and chemtrails.
I've never seen a chemtrail. I've only just seen like
If you
the
ever
trails from jets, and I've always seen them since I was a little kid, and every time.
the difference between a contrail and a chemtrail is that whenever they spray those nanoparticles, they like the contrails will disappear behind the aircraft. You can see them going away. The chemicals that they put in the air, they don't do that. They kind of stay across the sky, and they will expand and expand and expand and expand, and eventually you'll have a bunch of cloud cover that comes in, and then it might start raining after that, or you'll have some kind of crazy weather pattern that happens. And
That's really strange.
I saw a ton in Houston yesterday.
It seems like there'd be it seems like there'd be a lot of repercussions for that.
Start paying attention to the haziness of the clouds, because some of them are not normal looking anymore. Like they're really unusual looking, and then it'll usually be really cloudy after that.
It just seems like there'd be an objector. It seems like say Australia would be like because you're saying it's like very public, and you can go on NASA and look at it. It seems like
public now.
It seems like Australia at some global summit would be like, hey, could you guys stop fucking putting shit in the atmosphere?
Well, there are protesters. There's people like me and regular people out there, but these are government
No,
programs.
I'm talking like whole. It seems like
Yeah.
Country.
It seems like whole entities. Of
China
people.
actually used cloud seeding or
Well, China can't say nothing.
geoengineering before their Olympics. They didn't want it to rain during the Olympics. They didn't want it to affect their tourism and all that.
Yeah.
So they made it rain before. And
Interesting.
yeah.
Change the weather season.
So
They can't
I
say
mean,
nothing. They
so
pretty much-
you're manipulating the weather, which has consequences. It has
I mean,
consequences.
I think it's good practice for whenever we take over Mars, honestly.
Mars can be terraformed, from what I understand, in about 200 years by cloud seeding.
It's perfect. Yeah,
Geoengineering.
200 years. That's a good time span, right?
I wouldn't live there. The gravity is not
I just want to visit.
substantial.
I just want to visit.
I'm gonna have like osteoporosis
You could be
in 6
taller.
months.
We might
taller.
be able to visit the moon at one time before we die.
If you have enough money.
Yeah. Well, I mean,
I want to say, if I read somewhere,
It would be like
a trip
going-
to the moon would be like $100 million.
I think a trip after probably like 30 or 40 years, a
That's
trip
not
to the
very much.
moon will cost about the same amount as a European vacation.
Well-
$5,000. $5,000 you go to the moon for a couple days.
Well, our parents were also still wondering where their jetpacks are, so
Yeah, well.
think about that.
Well,
yeah.
we
I
have
want to
Tesla.
know where my jetpack is.
Exactly. I want to know where my jetpack is.
We have old Elon.
well, let me
Get us there.
Well, let me ask you this too, because this is something weird. I have a lot of arguments with people that they're in denial of certain things, like the moon landing. Like when I was telling my older brother is a moon landing denier. One of his main arguments is that he says it's impossible. Humans cannot go outside of the Van Allen belt of Earth, right? Which I say, yeah, I don't really think that's the case. I think that there's a lot of shielding
Right.
on these crafts. And then he's so staunch about it. He's like, nope, can't do it. We can never go to Mars. We can never go to the moon. We never did go to the moon. I'm like, look, dude, if there's people that are cleaning up the Fukushima meltdown, that is a lot more radioactive than the cosmic radiation. Like, there's a lot of places on Earth that are a lot more radioactive than just the vacuum of space.
Chernobyl is still radioactive.
Chernobyl is, yeah.
Yeah.
So I was
They're getting close to making it not radioactive anymore. They're treating it.
Oh, yeah,
Except
yeah.
for some of the animals.
The animals are radiated.
Are-
the animals are flourishing, actually.
yeah, but they're doing fine. I don't know.
They are flourishing, but it also changed them in some very negative ways, like
Yeah.
behavior-wise.
Right.
They're a little terrifying. I was actually just reading about that just a few days ago.
What do they do? Were they more aggressive? Or?
Yeah.
Yeah, because they're radiated.
Well, they were radiated.
You
Yeah.
really Fallout? I mean, come on.
But that's what I was going to ask is like the Van Allen. So definitively, and this is just kind of an overarching question, but once we leave Earth's protective shield, there's a lot of things that we have to deal with, but we can, right? Like we can shield a craft from cosmic radiation.
There's no 100% way to shield from radiation. So we could use lead, but it's too heavy of a payload.
Yeah.
You could use
exactly.
water, but it's too heavy of a payload because
Yeah,
it weighs almost 9 pounds a gallon. If you'll notice,
It weighs 1,000 kilograms
the-
per square meter or cubic meter.
yeah, something like that. So the astronauts, you'll notice that their suits are white. Space shuttle was white. The International Space Station is white because it reflects back more of that off
Yeah.
of the space station.
It reflects light, but I wouldn't. Well, I guess that's just another wave.
It bounced back
Yeah.
those wavelengths. So that's
Makes
one
sense.
way that they protect. I believe in the International Space Station they have a shielded room, a
Okay.
lead shielded room.
Yeah,
Just one area.
They probably brought it up in pieces over the years and constructed it.
I'm sure it took a long time to be able to do that. The International Space Station is huge, by the way. Like,
Really?
yeah,
You
they're
can see it.
Well, yeah,
they're-
of course.
yeah, you can see it
The
very
naked
well.
eye.
Yeah.
for the most
Yeah,
part.
it's got different wings on it. So each country, Japan,
Right,
Australia,
they all have their
China,
own.
Europe, they all have their own wing. In the USA, I got to take a really VIP tour of the Mock Space Station at Johnson Space Center,
Oh yeah.
and it is gargantuous.
I didn't know they have a mock. I didn't know they have one.
Yes, I have a friend that works there, so I got to
Field
take
trip?
Wait, there's a mock space station?
It is full size
Where?
at Johnson
in
Space
Houston.
Center.
Are you serious?
Yeah, I also got to go into
Dude.
Mission Control, the original Mission Control room with the red phone.
Aren't they like renovating it so you can go check it out?
I played on it. I got pictures playing on it.
I'm gonna wear my cowboy hat and my white dress shirt and the white vest. Yeah.
And then we got
I'm
to
gonna walk in there with a
go.
white vest.
We didn't get to go into the Mission Control room where all the people were working with the space station, but there's a little waiting room and there's TV monitors, and we got to talk to some of the Russian cosmonauts on there.
Oh wow.
And I have no idea what they were saying.
Field trip.
Because their English was kind of broken, but they were very hearty and they laughed a lot, and I liked them. They seemed pretty cool. And then we got to go
They have to talk to engineers all the time, so it's probably nice to talk to like a normal human.
Yeah.
Yeah.
Nothing against the engineers. I'm just saying.
And then we
You
got to
aren't
go
human.
into
You're
the
robots.
mission control for the Skylab, so which has no people on it anymore, but it's still operational.
Wait,
so
there's
that was
something
cool.
floating out in space that you can go to, but it's not. There's nobody in it,
There used to be people on the Skylab.
and it's still operating though.
Yes.
That's weird. There's like lights on and stuff. They probably turn the lights off.
It probably
to
has.
conserve.
It probably just has like data
it probably
collection
does,
things.
yeah,
on it.
data
Yeah,
collection,
it's just data
satellite
collection.
imagery and
The
stuff.
the space station does it? It has solar panels on it, right? Of course.
Yeah, like they're like the size of a football field.
Okay, I knew it's those big wings sticking out. I was just thinking about like
They use a lot of
turning the
gold.
lights off and saving battery.
Like
yeah,
astronaut helmets will have a thin layer of gold because of the thermal properties of it, because it helps to reflect radiation back.
Bling bling.
And so those solar panels are also lined with
Like-
gold, and also it has the melting temperature is a certain way. Like once they do something to the gold, it keeps them pretty healthy up there, so it can stay up there
Stay
without
up there for a very long
deteriorating.
time.
Yeah. So there's also the Solar Dynamics Observatory is this satellite that's specifically designed to watch the sun. Of course, it's not right by the sun, but it's close enough. But it's got a layer of gold on it. It's got these big, huge gold, whatever they're called. I can't even think about it right now. But
It's like a gold foil.
yeah.
Yeah.
And oh man, the Solar Dynamics Observatory is really awesome. They watch the sun like 24/7, and wherever it's located, I can't remember where it's at, where the office is that watches everything. But they have this big wall of like 9 gigantic flat screen TVs, and they put one huge image of the sun on these TVs. So and they'll put the sun under all these different filters, so ultraviolet and X-ray and infrared and all that, so you can see all these different aspects of what's going on the
Yeah.
sun that you can't see with the naked eye.
Right.
It's really freaking cool.
Where's that? That's in Houston too.
I don't know where SDO is. I have
Wait,
no
wait.
idea.
You talking about the sun observation?
Yeah.
Isn't that in Hawaii?
Oh,
Heck, I don't know.
I think
probably in Hawaii. Yeah.
I think
That's where
I
the
think that's in Hawaii.
Mauna Kea Observatory is.
Field trip. Yeah.
I want to go there.
Yeah. Right. I would go there for the beach, honestly.
I don't know where the SDO office is, but I know what they do. It's really cool.
You've been doing this for a while. You've been teaching for a while. You got your degrees and this kind of stuff. What's the thing that's most fascinating about it, of what you're studying?
I like relativity is one of my favorite things to talk about.
Yeah, that's right. You said that. Yeah.
But not just relativity, like the study of other dimensions or alternate realities and things like that. Because as
everything's made of strings,
quantum physics says that there's multiple realities or however many, like an infinite number of dimensions in existence, which I truly believe now. So there is this satellite out there called LIGO, LIGO, and it was built to detect gravitational waves.
Didn't they just now? That's the guy that was supposed to come and talk, right? Kip
Thorne.
Kip Thorne, yeah.
He was a Nobel Physics laureate. He wrote Interstellar.
Basically,
he wrote it and based it on what he knows about physics. So I don't know exactly why most people talk about LIGO and gravitational waves, but I know from my perspective what interests me in that is that, like, say a supermassive star goes supernova, and when it goes supernova, it releases all these bursts of gamma rays,
and we die.
And they can head towards the planet, and they can interact with our atmosphere if they bounce around on our atmosphere.
That's actually the prevailing theory of the Cambrian extinction.
Yeah. So the idea behind gravitational waves and alternate dimensions or realities is that within those waves that are produced from one of those gamma ray bursts, can actually house another dimension in those waves, and it can hit the Earth and bump into ours and kind of interact.
Yeah.
That's what I find interesting.
So maybe the dinosaurs were from another dimension.
I don't know about all that.
Or maybe we're from another dimension and we got dropped here.
It would be...
The extinction of the dinosaurs made way and changed the atmosphere of our whole planet.
Yeah,
so much.
We wouldn't be here if it wasn't for that.
Yeah.
We would not be here if that wouldn't have happened.
We were created by what killed the dinosaurs.
The only reason why we're here from that isn't really like any physical change of the Earth. It was just the fact that all of the very large reptilians died, so it left like a power vacuum in evolution for mammals to come up. It changed
our atmosphere. So during the period of the dinosaurs, not the birds. The birds
not
were
the
before.
Avian dinosaurs, yeah.
They lived millions of years before the big, huge reptile dinosaurs. They weren't even in the same time period. But during the time of the dinosaurs, there was
the pterosaurs.
there was more oxygen and more nitrogen present in the atmosphere than there is now. Which is why there was bigger flora and fauna.
If you go back even further than the dinosaurs, it was even more. It was way, way more oxygen.
And gravity of the Earth was different.
15% more oxygen. That's why they had like 15-foot long centipedes.
Yeah, because they could grow. Yeah,
6-foot wingspan dragonflies.
There was more nitrogen in there.
Was gravity different back then?
Gravity was different.
Yeah, because that's why they allowed the animals to be bigger, is because gravity was a little bit different.
Yeah, it was if you have a little bit less gravity, you don't have
it's like exponential,
all the compression of the spine and all that kind of stuff.
How would the gravity have been different?
I don't know. I don't know. That's just what I heard, man. It was in Jurassic Park.
No, there's evidence. There's evidence of all these different changes, like radiation and all that stuff in the different sedimentary layers of the Earth.
Yeah,
you can go back and look at those sedimentary layers and get all kinds of data from what was going on back then.
No, I know that the atmosphere was completely different because Precambrian, even before that, whenever the development of eukaryotic organisms happened, they flourished in all the primordial oceans.
Oh no, that was Jose Canseco that said something like that.
Yeah, I was like, that's wrong. I knew it was wrong.
Damn it.
But
I'm a shill.
Apparently,
I'm a gravitational shill.
But whenever the rise of eukaryotic organisms happened, they lived off of like chemicals, and what they did was they ate carbon and ejected oxygen, and they completely oxygenated our entire Earth in like 100 million years. That's why whenever the the dinosaurs and everything came around, it was a lot more oxygenated.
Yeah. And then there was more nitrogen, and nitrogen makes things grow big and huge. You know, you use nitrogen in your fertilizer, you get bigger vegetables and whatnot. Well, flora and fauna was giant back then.
Absolutely.
Giant spiders, giant mosquitoes,
giant fungi, giant everything. Everything was
probably
mosquitoes.
giant cockroaches. I don't know if those existed, but oh god.
Well, look up the giant centipede. It will freak you the fuck out.
Well, the God, what was it? That big, huge crocodile. No, I can't remember what it was called.
Megalodon, right? No, that was
Well,
a shark.
there was the megalodon. That was a shark. But there was like this big super croc that was like 60 feet long.
Yeah. Of course.
I'm so
trying to remember
glad
what
I
you were
don't live
talking
around
about, yeah.
stuff like that.
Well, they had bigger things to eat back then too. So
Yeah.
Well, that's kind of how they are now. Is basically they live until they can't feed themselves anymore.
That's why the megalodon's not alive anymore. Just in case anybody's listening to think it is, because that's a common thing. It's impossible. It's impossible for it to be alive.
Well, the coelacanth is still in existence.
It's too cold.
And people thought that those
Oh
were
yeah,
extinct.
that is really dope.
What?
The coelacanth is this fish that's basically
it's
the
a 300
bridge
million year
between
old
land
fish.
and earth animals. It was the
It has
first.
bony.
It has the wrist bone.
Oh yeah,
That's the connecting thing
Right.
between land and
Yeah, well, we
sea creatures.
definitely came from the sea.
Yeah, but it's still alive. But it's only like 400 pounds. It's not.
They
not
found
60
coelacanths, and we thought that those were extinct. Giant colossal squids exist.
that's right.
Nautiluses are still. They
We know
exist.
more
Yeah.
about space than we know about the ocean.
Well, that's one thing.
We don't know
too.
anything about the oceans.
That's really one thing that's really interesting about the ocean, and we're talking about space, is one thing I always find really fascinating, and every now and then it will pop up in my brain, and I'm like super stoned or something when I'm thinking about like, whoa. But basically, and this is why I know that aliens have to exist mathematically, just like statistically, there's definitely aliens in the universe, because if the sun were just to vanish from existence right now, and the Earth jettisoned off through space because it wasn't gravitationally locked to the sun, there would still be living things on this planet because because things live on volcanic vents in the ocean.
Yeah. So the life that's around the geothermal vents is really interesting. Okay, so we're carbon based,
Right.
and we get our energy from the sun, and plants get their energy from photosynthesis. And all that.
But those things are
those
chemosynthesis.
things are methane-based
Right.
creatures.
Yeah, and gravity really has no effect on them because
and they
they're being
literally
squashed by the ocean.
They only exist through chemosynthesis, not
And
photosynthesis.
what is really strange
Photosynthesis,
is that even though they're methane-based creatures, like there's tube worms, those red tube worms,
Mm-hmm.
the plasma within those tube worms is almost identical to the plasma in human blood.
Yeah.
But they're methane-based creatures, so we have methane-based
But
tube
what
worms
do you
and
mean
shrimps and
methane-based?
crabs.
Like, they're not based in carbon?
No.
They're not carbon creatures.
So they don't have
No.
DNA?
No, their DNA is different than ours. Their basis, their chemical makeup, our basic chemical makeup, we are mostly carbon, like in our bones and stuff. They're totally different. They're a methane-based creature.
Oh, okay.
So they get their energy differently. We get our energy from the sun. They get their energy from those geothermal vents.
Chemosynthesis, yeah.
But even though we're so different,
they eat like
they're
sulfur and
so
shit.
similar.
Yeah.
So there could be other creatures out there in existence.
And that's
that
what
are
I was saying.
Based
Is like,
off
I'll
of different
think
stuff.
about that. I'll be like, if we just
Whoa.
jettison off, we'll all die. Trees will die. Fish will die.
Extremophiles, tardigrades,
Tardigrades,
water
yeah.
bears.
Well, tardigrades
survive.
die too. They'll just take a lot longer to die than us.
But they can live with no oxygen. They can live in extreme hot, extreme cold.
no. Well, there's a difference between living and not dying. So there's
go into a hibernation
So there's a
state, right?
humongous difference between
They can survive.
living, right? But living means viable living, flourishing.
Right.
A tardigrade can just not die.
Yeah.
It can hang on to the outside of a spaceship.
Kind of like a
Go out there,
jellyfish.
go out there, go for a couple of laps, and come back.
Do you know that jellyfish have no expiration date?
Well, the immortal jellyfish doesn't.
They just
But that's
can
just
go on forever.
that's one species. That's
Yeah.
only one
We
species.
think trees can do that too.
It's only one species.
We think
of
trees
things.
live forever, basically.
The longest living organism on the planet is actually an algae-like thing in Antarctica. It's
It's like an expanse,
kind of it's
some kind of
and it's
mycelium.
the biggest cluster of it is 2,700 years old.
Wow.
It is an algae-like thing, but
Yeah.
I can't. I'm trying really hard to think about what it is. Anyway,
Well, are there-
but tardigrades cannot live through that. That's my thing. I think people hype up tardigrades. Tardigrades suck.
They can survive some pretty extreme conditions.
They can survive, but they won't live.
There's
There's
other
nothing for them
kind
to
of
eat out there.
bacterial things that can live through that stuff too.
Oh yeah, of course, yeah.
Yeah, and the thing about that is a lot of them can go into like this hibernation where they're like not active or anything, and then
And
you
come right
know
back
say
up. Frogs do
that
that
say
too.
the ice melts and the polar ice caps, and all of a sudden you have live viruses.
Oh yeah, you talking about
Dun, dun.
you talking about big viruses, the
Like
ancient
the thing,
yeah.
right?
Yeah. There's
Just like the thing.
Yeah,
Just
so
like the thing, yeah.
even though human life would cease to exist, there would definitely still be something going on.
Well, viruses aren't alive, but yeah.
Well, Allison, do you have anything? That's coming up or anything to pimp out?
Anything to pimp out?
Yeah, like special events or anything happening at Lamar or anything.
No.
No.
No, we
She's
did.
like, I don't care about that place.
I will say this though. So we were gonna have Kip Thorne come and speak. He's
Yeah.
the
Word.
Nobel Physics laureate that
Yeah, I
wrote
told you about
Interstellar. And he had to reschedule, so he will be coming back. I have no idea.
You don't know
though.
when?
I don't know when.
Okay, we'll have to get that date and then share it because
Yeah.
we were gonna go. I was gonna go.
Yeah, let's do.
We actually hit him up to try to get him on, but it was a far
No,
fetched thing.
I don't have anything to pimp out because it's almost summertime.
Yeah. Oh, so you're gonna pimp out? I'm getting the hell out of that school.
NDGT's coming to Houston.
I'm
Who's
gonna.
Neil deGrasse Tyson.
Oh yeah.
Oh yeah.
Coming to Houston, I think in June.
It wouldn't be anything interesting. He'd just stand there and a bunch of people would yell.
Oh, yeah.
Now, if we were talking about, God, don't laugh at me if I mispronounce his name, Michio Kaku.
Oh, yeah.
Yeah. Now, he's an interesting guy.
Yeah.
Very
Is he-
interesting.
Yeah.
Michio Kaku?
Yeah, I don't know how to say
What
his
does
name.
What does he do?
He thinks he can think in 12 dimensions.
Oh. Okay.
He is a big
He's- yeah.
quantum theorist.
Oh.
He's a quantum
That's something
theorist.
we had to touch on one time.
He's proposed that dimensional theory of 12 dimensions. I mean, we live in 4 dimensions, you and I and all of us here, 3 dimensions, the width, height, and depth, then 4th dimension is time. And
We perceive the 4th dimension.
yeah, we perceive in 4
But we
dimensions.
live in 3 dimensions, but we
Yeah.
perceive the 4th dimension. Creatures that are below us dimensionally, like say flies and fleas and stuff,
Or ants, they're
they don't
two-dimensional creatures.
they
yeah.
don't perceive
time.
time the same. No, but they don't perceive dimension the same
No.
that we do either.
Read the children book, Flatland.
Like dogs don't have a concept for time.
Nobody has a concept for time but
Well-
people. Time is just relevant to you and me. It's
Yeah.
relevant to the observer. You can have people witness an accident and have different timelines of what happened
Right.
because of their,
Perceptions.
because of their relevance to where it
Perceptions,
happened. Yeah, I mean, people have been convicted of murder like that before.
Yeah, they're starting to
Wrongfully
throw eyewitness
convicted.
testimony.
Yeah,
Yeah.
they don't really take eyewitness testimonies very seriously anymore.
Right,
Yeah.
because of
Because of the
that.
science,
Yeah,
yeah.
All right, we're getting on some
specifically that.
weird tangents. Okay. Well, we're gonna. I guess we'll round it off and call it an end of the show. Thank you so much for coming, Alice.
You're
Amanda.
I'll answer to Allison. It doesn't matter.
I always fuck up a name at least once.
Yeah.
Thanks for coming. Did you? Did you have a good time?
Yeah, I had an
Yeah.
awesome time. I'll come back too if you
Yeah,
want.
for sure. Yeah, we'll have to
I'll
figure out
collect
something.
some new stuff going
Some
on.
new stuff.
And
Yeah, if we have some new things
We were
happening.
kind of all
in
over the place
science
with
world.
tangents today,
Well,
but maybe if we reined
see,
it in.
that's what makes my job interesting though, is because, and I'm not even kidding, every single week there's a new discovery.
Oh, yeah,
Yeah.
absolutely.
And so there's
bet-
something new for me
I
to
bet
learn
you're
about.
never bored.
Actually, before we get off, there was 2 new auroras discovered. So there was this beautiful blue aurora
Steve.
that looks like a big streak. Yeah, and they named it Steve.
Steve.
I love it because it's such a simple name. Everything else in science is so complicated. So
They made
call
up
it
an
Steve.
acronym afterwards, but yeah, Steve.
So
That's
Steve was.
It must have been British who
Yeah,
discovered it.
Tell
Steve
us
was
about these
purple.
auroras. Yeah.
It's a purple streak instead of the green and blue
Yeah, yeah.
curtains.
Uh-huh.
And then there was another aurora that was found that was purple. No, it was blue. Steve is purple. These auroras are blue. God, I can't remember what happened.
These
It
were
has
an-
something
these
to do with
were-
the
these were,
other magnetic field that was discovered.
These were in the Antarctic, though, weren't they? Were they in the southern pole?
Yeah.
Yeah.
And I believe, if I can remember correctly, they were in some weird places that auroras have never been known to exist.
Climate change there.
Climate change is
Word.
real.
Word.
Could
It is
happen.
real. Get hype. Get hype. Climate change is real.
You can
heard it
change
here
the
first.
climate of where you are by cutting your trees down.
Yeah.
Yeah.
You know, you make a carbon sink where you live, and
Carbon sink.
you make it hotter.
Yeah,
You make
it's
it
true.
hotter. I mean,
my
you can
goodness.
change your climate.
It's very, very easily provable that climate change is real, and if you don't think
Yeah.
it is, then you're just being willfully ignorant.
We're gonna
Yeah.
we're gonna end
We're
on
getting it
that.
on that.
Yeah.
Thanks everybody for listening. This has been A to Z podcast with Amanda and Allison, and we've just talked about some space time stuff. Aaron, say goodbye.
Goodbye.
All right, guys. So that was episode number
29.
29 in the books. Thank you to our guest Amanda
29
Allison.
episodes.
I know, it's kind of cool, huh? But yeah, thank you to Amanda Allison. You can see her at Lamar if you want to attend there, obviously.
I think she's pretty. I think she might be on the Facebook group. You might be able to find her somewhere and reach out to her. Or
If you have any questions or need any clarification, yeah,
for sure, send us any questions. We'll see if we can get an answer out of her.
we definitely want to facilitate sort of a call and response to any of our previous guests. That's what this thing's all about, is facilitating like communication between all that. So, but again, thank you to her. We also have something we want to say. We have launched our Patreon, and if you like what we do and you want to support us, please head over on to our Patreon. What's the
Patreon.com/A2Z podcast.
That's it.
A to Z BMT. Sorry,
That's
/A to Z BMT.
Y'all heard Zach. So if you like what we do, it really helps us if you just gave $1 or whatever. And I don't want to sound like an evangelical
Hey, Mom.
preacher right now, but is your mom on the phone?
Yeah. We're in the studio.
You just gave away
Okay.
the
Do you
location.
see the two glass display areas?
Yeah, I'll go let her in. Let's
yeah,
finish.
Aaron's
up,
coming to get you. We're gonna finish this read. We're coming right out. Okay, 1 sec.
All right. Well, anyway, like we were saying, go to Patreon if you feel like supporting us, because we don't have much
You can
advertising.
give $1 a month, $5 a month, whatever you want to give.
We
and
ain't gonna
it would
stay
help
in
us
pearls.
out.
Yeah,
it
we
would.
just-
It would help us keep the lights on, keep the bills paid. Maybe we can finally get internet in this place, and people will come and use it.
All right. Well, thank you guys for listening. This has been episode 29 with Amanda Allison.